Today I want to talk about a CLI tool which I built to optimize test discovery and execution, and then also talk about how I adapted this tool to use with AI to enhance my agent context window consumption and effectively like tokens burned per test run as well. Within the org, we had our own CI/CD pipeline, which was used to do all of the test runs, linting, type checks, etc., to check for failing use cases, and then I guess reject the build before it can be checked into master. But this would sometimes take upwards of like 8+ hours or even a day. Like typically, you'd send your change and then wait till the next day to see if it's passed or failed. And this right here is a problem. It's a huge bottleneck, because then if your code failed for whatever reason, maybe there was some tiny little linting error that you didn't catch before pushing to remote, you'd effectively lose a whole day in turnaround time on that specific branch or that piece of work that you're doing. So yeah, within the ecosystem of what I was working with, we had 3 test suites. We had Jasmine, and Jasmine, and VTest. Right, so these were our test suites, 3 of them, and typically any one of those tests could fail, and this was just on like the JavaScript TypeScript layer, like within the front end part of the ecosystem mostly. And what I wanted to do was build a CLI tool which a developer can run. So CLI tool which the developer would run, and when they run this tool, it basically finds all of the dependent tests which are related to, let's say, some changes. So you've got your PR, right, pull request, and you've got, I don't know, maybe 30 changes on this PR, and these changes may impact, if we have, let's say, tests, so test, T for test, these might impact, like, let's say 150 tests. Now, how we find that out is like we walk down the dependency tree of the module declarations and figure out, based on these 30 changes, like which things are impacted effectively. And then I believe there was also some kind of regex check on the naming convention to see if it was like a .test or whatever for the different naming conventions we'd search for within Jest, Jasmine, and VTest. So we'd basically pick up all these changes. The CLI tool would find out these tests here within one command and then pass it back for effective execution. Now, each of these test suites have their own test runner, and the CLI tool was built in such a way that it was ambiguous of which runner it would execute, so that we could define the implementation details for, let's say, Jest. So this one's Jasmine, this one's Jest, right? So Jest has its own unique implementation here, which once we find out which of these 150 tests relate to Jest, we pass these into the runner for Jest, boom, and execute them. So Jest has its own CLI command. I think Jasmine was an executable called Chutzpah or something that you need to run it against, and then VTest was effectively a fork or like a predecessor to Jest, and the actual test runner in CLI was very, very similar if you look at the documentation for these two. So VTest and Jest, very similar. This one was kind of unique in the approach we had to take within this CLI tool. But effectively, having built this out, the CLI tool was then, you would pre-configure it. I think I would cache. So I defined a config file. So I had a config which had paths to each of the actual runners. Because, for instance, with Jest or the Chutzpah executable, that might be somewhere that lives specific in the project structure. So if we have our project here, right, we have that executable in the binaries somewhere within the dependencies that have been installed through Node modules, I think. And the config that is associated with this CLI tool would list, like preload those paths. So the config would be able to tell you this is exactly where the executable is, and this way we can avoid having to do a search, like a regex search or like a grep through the whole repository structure to find this executable, or the Jest config file or the VTest config file, because these all live in like unique places in the project. And for Jest and VTest specifically, we would have like multiple of them within the project structure. Because we were working with kind of like a monolith. So the CLI tool itself would then find the config file, walk down the dependency tree, find all the related tests, and run them. And then the output of the CLI, so let me see if I can do a big line here. So this would effectively be the input, is this PR. So this PR is going in here. This is the input, the config file defined in the repository. And then the output of having run this would be a comprehensive list of, let's say, vtest, jest, Jasmine, right? So we would have a list that says, let's say, 5 failing tests. 5 failing tests here. 1 failing test here, etc. Whatever, in these 150 tests that we found, and maybe 0 for Jasmine. Whatever that looks like, the CLI tool would be responsible for kind of forking out that workload, running the tests, and then outputting the failures, and also kind of the successes. And before we had like AI integrated in our workflow, or like before it was effective, this process was still very developer heavy, because the developer would get a comprehensive list of tests to fix based on these dependencies, but then it would be their job to fix it. So I believe this tool, I built it in maybe 2024, early 2025, when we were still kind of prompt engineering. So then I would go off with my failed tests and attempt to fix them as best I could using prompt engineering. But since then, we've kind of come a long way, and I've been able to adapt the tool for AI use case, right? So my initial implementation was using MCP. So what I wanted to do was spin up an MCP server with this tool preloaded, baked into it as a node dependency, and like an NPM dependency. And then we could effectively just allow the MCP server to execute the things, pass the failures to an agent, and then the agent could recursively go ahead and like fix all the failing tests. So with that MCP, it would effectively call the CLI tool, the CLI, the test runner, and it would then pass its output to an agent. So let's do capital A for agent, and then the agent would just like go in a circle, fix, then back again to the CLI, and it would just do that like X amount of times until everything is fixed. So until we have like a success output, right? However, as an MCP, it kind of made sense in a way to have it as an MCP, because you could then implement some kind of caching layer and all this stuff, and like it could then operate with other tools within the ecosystem at the organization. So that was the original plan, but there was a bottleneck in that my workflow at the time, I kind of adapted to have, let's say, 3 different workspaces where I would have the repos configured with, let's say I would pull in all the repos in each of those workspaces and maybe be working on 3 tasks in parallel, right? In each of these workspaces, with the binaries precompiled so that I could like have that stuff just running and be more productive, I guess. So I had those 3 workspaces configured, and the reason why I couldn't use Git work trees for this is because at the time there was like a bug with agents using, or just functionality that didn't exist with Copilot's inbuilt system, and it didn't really work with the Git work trees. So the MCP struggled with using these different workspaces because it was often the case that the dependency structure on different branches was different, right? So it would need to then fork out a different process for each of the workspaces and handle like an internal CLI command for each one of them. And that was kind of overcomplicating the system. So what I ended up doing was changing this to a CLI tool. Well, like not changing the CLI tool exactly, but adapting this to an agent skills implementation instead, where the skill would be aware of the CLI tool, and it would exist either as like a globally installed skill on the developer's hardware, so it could either be global, or we could install it directly in the repository, right? So if the skill's in the repository, developers don't even need to know about the CLI tool, because the agent will just pick it up and run and you could basically tell the skill to do it before they push to remote, before they trigger like a CI/CD run. When they push from a repo, the agent intercepts. So we get our agent intercepting the change, running the CLI tool, and then effectively getting an output and doing that recursive loop of fixing. Now, what's interesting is you would probably think like, okay, at this time we have maybe Claude 4.6 when this tool is built, and you would think, why even have this tool? Like, this tool is just a middleman. Like, there's no point of really having this tool, because you can just ask an agent to do it yourself. And to that, I would agree. However, there was one huge benefit of leveraging the CLI is you would be offloading the compute from having an agent run multiple tool calls. Like, if I ask my agent, run all these related tests, fix my changes for any failing tests, right? The agent then goes off, forks off a bunch of different tool calls to find those dependencies first and foremost. And because we know agents are non-predeterministic, every time you'd ask it to do that command, you would get a different list of dependencies. Now, from testing, I actually created like a profiling tool that I could compare like approach A versus B. A would be like full CLI run. B would be asking the agent to do it. The agents were roughly 95% accurate at the time using Claude 4.6. And that was good enough, right? Occasionally it would miss a failing test, which then would be surfaced in the CI/CD pipeline. But if it wasn't surfaced in that CI/CD pipeline, or sorry, what was I saying? If it wasn't surfaced in that CI/CD pipeline, the agent would still basically call about 20 to 24 tool calls to do the whole process of test discovery, test execution, and then finding all the failing tests, whereas forking the compute off to the CLI tool, so the agent would do about, let's say 20 plus tools. The CLI tool would be one tool call. It's the CLI, right? It's offloading the compute to the developer's hardware, but it's also deterministic. So every time you run this CLI tool against the same set of changes, it'll find the exact same dependencies, and that's something that is actually quite good. It's quite nice because you can leverage the skills to allow the agent to run the CLI, have the exact same output every time it does, and then be confident that you've surfaced all of the failing tests. And then as a subsequent result of this is because you're calling less tools, the input-output layer is cleaner, and the agent is actually having to process less tokens and less context window. So at the time, we didn't really have as good context window compression systems, but like things have come a long way since then, right? But at the time, context window was everything. So this tool actually reduced context window consumption by about 4x on average, based on all of my profiling. And it also reduced token consumption by the same amount, approximately. And these are just averages. Now, one big bottleneck was, this is only like JavaScript and TypeScript test frameworks that were supported, right? And like most of our code was written in .NET. So like we didn't have the same layer of support for maybe 80% of our tests that were written. But I was kind of working on adapting the tool. There was an MCP which used semantic analysis, I think using Roslyn analyzers or something, and indexing a repo. But that MCP that I was going to integrate into the CLI tool had the same problem with like workspaces. So if you had any more than one workspace, the semantic analysis that would be like indexed for all of the repos just wouldn't work, because you would then effectively need to fork off 3 different MCP servers and have them run in parallel, which on the laptop's hardware, it just wasn't feasible, right? So I kind of struggled to get it working with .NET, but I mean, that's a conversation for another day. So yeah, that's a tool I built recently, and I feel like it's slowly being phased out in terms of its utility, because agents are just getting so powerful. Like a 4x token consumption optimization, and the actual downside to using the CLI tool is it would burn through your local hardware's compute power, right? So like I would be running 90% of my processing power on my laptop. So like I would basically just take this as a glorified coffee break, run the CLI, go make a coffee, go touch some grass or something while I wait. Whereas if you're doing like asynchronous work and you're working in 3 different workspaces in tandem or parallel, you kind of fork it off to an agent, take the lazy approach, and burn through more tokens. But yeah, I'm very much in favor of like deterministic results, which is why I liked using the CLI tool. And the skill integration was actually a really, really interesting part of this, because you could just autonomously run the tool and developers don't even know it's running. So they'll get the full benefit of like the agent just recursively fixing their tests before pushing to the CI/CD portion of our like deployment lifecycle. So yeah, cool. See you later.